we're going to do a quick wrap up. What are we even doing in this class and why is it important? So as you probably remember, and if you don't, I can't help it, we've been doing different data sets. These data sets are essentially showing us different variables. So first we do the ice cream. You have consumption, which is the dependent variable, to see if this independent variable, temperature, affects consumption. And you also have price. So notice all of these variables are quantitative. These are continuous quantitative variables: price, temperature, consumption, etc. So we use the LM function linear modeling. Pretty easy, right? So if you've been following around, then we can create a graph, a beautiful graph using ggplot, which isn't that tough. And then we see an outlier way up here, but we see it's going up. That's why it's statistically significant. And then we learn how to interpret the results. Now, remember, this could be anything. Right now, there's a problem with inflation. What they've been noticing is, just to apply it to something topical, is that the price, even though it goes up, consumption of whatever you're measuring isn't going down too much, and it's not statistically significant. So as long as prices keep going up and consumption isn't falling at rapid rates, people are going to keep on increasing the prices. That's where inflation comes from. It comes from, a broad spectrum of different things. So you've got inflation, the increase of prices due to supply chain, possibly tariff, taxes, and other things. But then you also have people like money, so they start bringing up the price, and if they notice consumption isn't falling, woohoo, we're going to keep on increasing the price. Temperature could be anything. Temperature and, say, the consumption of gas. We want to see if people are, driving more, measured by gas consumption, during the summer months for vacation. And if that dips and there's no statistical significance, maybe people are not going on vacation as much. But the goal here is then there's a hypothesis. The null hypothesis: there is no statistical significance between temperature and consumption. There is no statistical significance between price and consumption. That's what we're trying to look. And is it positive or negative? That's pretty interesting to do. And then you can build a graph and you can apply this to just a broad range of different things. Then you look at affairs. We're seeing now we have different variables, right? We have gender as the independent variable, which is nominal, male or female. I know there's more types of gender now, but just to keep it easy, right? I'm hip. So even though I'm like 97. So you've got gender and seeing if gender is influencing affairs, meaning you have more affairs if you're either female or male. Now, don't forget, this variable could be measuring something else. Let's say, for example, you're a lawyer, you get something, a client, and she says, hey, I'm not getting, say, a fair salary. And you say, okay, I'm going to look statistically at this. So you look at the company's record. This is gender, and this isn't affairs. This is salary, right? I got my disappearing pen. So you basically then run to see if there is a statistical significance, and you find out, oh, females are getting a lower salary than men. So this can help your case. So this is one of the things that's very important. This isn't just for what we're learning now. This is applicable to different careers, right? This might not be gendered. If you want national security, this could be, a type of drone, and how many, well, I don't want to say people because that's lamentable, but this over here is how many weaponry, right, are being attacked or being targeted or being successfully destroyed depending on the different type of drone. So then you'll understand better. That's exactly what artificial intelligence does, is that it starts looking to see, the kill chain, as if you're taking another class with me on data, artificial intelligence, and national security. That's exactly what they're looking for, right? So then they can better understand what military equipment is working better. Same with penguins over here. We did more recently. Look at this is species, and this is bill length. This could be any type of but nominal variable. Remember this but it's still in an independent variable, but the dependent variable, bill length, build depth, flipper, etc. Body mass is still quantitative. So that's what's important. So with affairs and with penguins, these are still the dependent variable, the result are numerical. It just so happens that this species or island are nominal variables. Nominal meaning there's no order to it, just categorical, religious, right? This could be anything, religion and salary, et cetera, et cetera. So you kind of get the gist there. And then we go to Titanic and we start seeing survived and then sex. Wow, this is totally different. This is logistic regression because all of a sudden the dependent variable is not numeric. It's either yes or no. Yes or no. They're mutually exclusive binomial variable. So you've got survive and then two attributes, yes or no. And it's like, okay, then you've got the independent variable, the cause, female or male. So this could be anything. There's a lot of data, like this could be sex, male or female, and who did you vote for, Trump or Harris? Is there a statistical significance? And then if you're, say, doing political campaigns, right, you'll say, oh, men are not voting for Harris, so Harris campaign has to start attracting men, just for example, right? So this has to do with a lot more than just this interesting survival data set. Passenger class, this could be, say, class, first, second, third, and who do you vote for, Trump or Harris? Okay, Trump isn't doing good in the lower class, so Trump has to start, if he runs again, is he running in 2028? So then, they have to start focusing on the class. This has been done before. Ronald Reagan wasn't doing well with the elderly statistics were showing. So that was before you were born. And his advisor said, okay, let's start making commercial towards the elderly to kind of bring the elderly into our orbit so they vote for us. That was Ronald Reagan, a president during the 1980s. So this is very important in a broad spectrum of different ways. This could be sex and promotions, right? Are you more likely to be promoted, yes or no, if you're male or female? This could be religion. This could be just so many other things. And then as we can see, we can ggplot these. This is the species. That's a box plot. And this is a cool survival count. So you look at this. And again, this could be, say, promoted or not promoted, etc. But this is the amount. I like this type of graph because you got male, the legend, and this is the amount of men that didn't survive. This is survived. So even though there's more men, obviously, on the Titanic, you see they are more likely to die. So chivalry will never die. So this is the amount of women that would die. This is the amount of women that would survive. So it's statistically significant here. And these graphs are really good because what they can do, whatever you're doing, you can learn how to do ggplot. You learn how to make a graph, and then if you're doing a presentation, say you're an honors student or you're any type of student, they go, oh, wow, that's a cool graph. Oh, I made it myself. You really impress people because, most of the time students just, cut and paste their graphs or copy and paste. Oh, I got this from The Economist, the New York Times, but here you can make your own graphs. Well, I hope you enjoyed this. This was kind of wrapping up, remember, and then really quick, I did want to stress, then you do a hypothesis test, right? The null hypothesis is that there's no relationship between, say, sex and survived, whereas an alternative hypothesis would be you're more likely to survive if you're female, or you're more likely to survive if you're male. And that's what we're testing here. So very interesting. That's applicable to your careers, life in general. Take care, everyone.